Hi YouTubers. Today we're going to look at the technical bits of a lecture and workshop about using relational tables and SQL in ArcGIS. Um, Previous to these technical issues, we went through some conceptual things about vector relational data models and interoperability and encodings for sharing tables with people. Which you can check out here on my tutorial page, www.pbcgis.com/lookup. Has many links to the online help documentation and things that you can scroll through, and a tutorial data set if you want to follow along at home. The gist of this technical video is to demonstrate the use of some of these vector relational methods. It's an interesting set of tools invented by a guy named Ted Codd that can use tables systematically as representations of things and conditions, and a set of logical tools that allows you to do queries and sorts and summaries, and even to make systems of tables that can explore the relationships between things and conditions in the real world. So we're going to demonstrate these things using ArcGIS. These tools and these methods and ways of looking at the world are actually an international standard, and they're employed in every single analytical tool. Not everyone, but most of them. ArcGIS has its own interfaces for these, but we'll be talking about the grand concepts as we actually dig into the buttons and menus of ArcGIS. Our exploration is going to involve this very interesting data set from MassGIS. It looks at land use and land use change. It's useful to think of GIS or any sort of data as being a collection of observations. You can read the metadata here talking about how these land use data, which are essentially polygons associated with land use. And the metadata will tell you how the land use was observed in 1971, 1985, and 1999 using aerial photo interpretation. These observations were recorded in a table. The table has attributes, columns if you will, that use a 21 class land use code to record the observations from 1971, and also 85, and the same 21 category class is used in 1999. There's a 37 category class that was used in 85 and 99. It's a long story. Here are the codes for the 21 class land use categorization scheme. And so this will be useful. The metadata is very useful. It's essential. So you're going to have to read it. Looking at ArcGIS, what we're going to look at today is land use and land use change in Cambridge and Somerville. So here's the tutorial data set. If you download that from the web, you'll see that you get a zip file called tutorials, categories tutorial, and it's got source data from MassGIS here. Here's the land use shape file. There's a layer here that MassGIS has given us, and we also have some project data in this folder that we'll be using, and the tutorial start MXD is here. Brings us to this point here. So let's add the MassGIS land use polys. And we're going to look at the attribute table for this and get an idea of how a table can represent a collection of things or features. Each feature is distinguished as having a combination of these attributes, the land use as observed in 1971 using the 21 class coding scheme, 85, LU21 1999 has another set of observations on the same polygon using the same category scheme from 1999 aerial photography. For each of these, we have area, acres, and the length of the perimeter of each polygon. So we have the codes basically. Also this tile name, if you look in the data dictionary, tile name regards the town ID, and you can look up town IDs here. I've already sort of figured out what the town IDs for Cambridge and Somerville are, and that'll come up later. So it's a table. Each row represents a thing, which is a polygon that has associated land use observations referenced. So let's dig in and see what we can learn from this. First of all, it's a little bit kind of bland looking. We might get more information if we, instead of adding just the polygons, we add this land use layer, which will actually provide some styling for us, provided by MassGIS. And these, as we learned in an earlier tutorial, this layer, if you double click on it, you can see that it's referencing the land use poly dot shape. And among the layer properties, you can see that MassGIS has taken the land use codes for 1999. Whoops. Let's undo that. Open this again. These 20 or the 37 class coding scheme, and they've applied these nice conventional land use colors to the 37 codes, and they've also entered these nice labels. And this is a lot of good work that MassGIS provides to us. You can imagine a lot of hours went into carefully choosing these distinct and meaningful colors for such land uses as cranberry bogs and heath. So that's a nice feature. We're going to be looking at more of these layer properties in a second. Let's take a look at what we can do with this table and filter it with some SQL queries. We have a set of things, and those things are distinguished by their attributes, but they can also be associated by their attributes. We can ask which of these things is not like the others, for example. And the way we build a query is we could go to Select by Attributes here at the top of the table menu. And we can build an SQL expression. Here's our little starter expression. Every SQL expression begins like this. Select all rows from the table land use poly where. It's looking for the where clause here. And it will ask which polygons, which rows, had a value for LU21 1971 equal to 16. 16 in the 21 class coding scheme is industrial. So in effect, I am asking which polygons on this land use map were coded as industrial from the 1971 aerial photographs. I'll apply this, and you see that 241 polygons are selected, and we can move this table out of the way, and you see here's the polygons that were industrial in 1971. Industrial, the conventional color is purple, and you can see that most of them are still industrial. I think, there are a few out here that are no longer industrial. Um, and that's a kind of an interesting question. What if we wanted to see the polygons that were industrial in 1971 and in 1999? I'm using the 21 class coding scheme. Were not equal. Here's the not equal to operator. It's a less than, greater than sign. 16. Select all the rows from land use poly where the value of 1971 land use is 16 and the value for 1999 land use is not 16. And so this will be some reflection of industrial conversion. So we'll apply that. You can see the selected polygons here has changed, and now we see these polygons, they're no longer industrial, and that's why they're not purple. We can zoom back over here and take a look at the alewife area. A couple of changes happened there. This one seems to have changed maybe to transportation use. That looks probably like it's probably, oh, the alewife T-stop. Okay, yes. Probably some of us remember when that was built. We can look at the table now. So one thing to keep your eye on is we have this expression, and we can bring back our table. And note there's now 44 rows selected. This is kind of a special set of polygons that are all related according to the fact they had land use in 1971 as 16, and the land use in 1999 is not 16. And so this is a virtual table. Notice how I'm clicking down here on the bottom. We can view all the records, and there's 44 selected. If we scroll down, we might be able to find some. We go by very quickly. There's 5,926 total polygons, and if you click this button, Show Selected Records, you'll see just the 44 polygons that are selected. And this is in effect, and to use a relational database term, this is a view. These 44 records or rows represent a virtual table that is the embodiment of this expression, this where clause. I'm just going to do a thing here. I'm going to see if I can copy this out of here and paste it into my text editor for future use. That expression kind of is a shorthand way of defining a new table. And one neat thing that we can do is, we'll put this away. I'm going to make a copy of this layer, paste it into the data frame. Now we have two identical copies of land use 1999. This layer I'm going to rename Industrial Conversions. And it's still identical. It's still pointing at our friendly shapefile in the folder. But let's look at the properties now. You can just double click to look at the properties. You can see the source still pointing at our land use poly.shape. Fine. Let's now look at this layer property called definition query. And I'm going to try to paste my query into there. That does not work. But we can go to the query builder, and maybe we can paste it in here. Nope. Okay, so we have to re-enter it. That's fine. That'll be a good little review. When you're entering these expressions, it's very helpful to, we won't be able to go through all the possibilities here, but if you click this help button on the query builder, you'll see a whole lot of example SQL expressions using dates and character strings and arithmetic and all kinds of functions for comparison and logical testing. So you should definitely look at that. But for now, we'll do something simple. I'm just going to say select all the polygons from land use poly where the value of 1971 land use is equal to 16 and the value of 1999 land use is not equal to 16. And so we'll just push OK. That's now the definition query for this layer called industrial conversions. We'll push OK on this. And now you see that I have just these polygons here, just the industrial conversions. And we can go to the selection menu, even if we push clear selected features, which is a good thing to do occasionally. You'll see there's some land that converted up here from industrial to that green tone, urban open. And down here, some land, this is the Arsenal Mall, I think, that converted from industrial to commercial. So we've now got a view, a restricted set of this table, saved as a new layer here. You can look at the properties and see that the source is still, we haven't created any new data, the source is still land use poly.shape, but we're just looking at a filtered subset of that. And if you look at the attribute table, whoops, it looks like there's nothing in there, and that's because the attribute table is stuck on showing selected records only. There's only 0 selected of 44. If we want to see all 44, we have to toggle it back to show all records here. This table only has 44 rows in it, and these are the features that are associated with one another based on our logical expression. Fun things to do with this. I want to just kind of remind you now where we are. We've looked at queries. Let's do a sort, and then we can look at a summary using SQL. In the normal language of SQL, a sort would be called order by. Let's find the largest area that was converted. If we sort ascending or sort descending on area acres, we'll see that the largest polygon that was in this category of polygons is here. We could select it from the table and look. This must be out of our view extent. Let's see. There it is. Now some of these polygons are sort of close together. So if you, one thing that you might want to do is do a summary. I'm going to push the clear selection button, which is a good thing to do before you try any of these relational operations. What if you want to know the total number of acres? You can summarize the selected rows here. And this would work even on the parent table. If you just had a certain number of rows selected, you can just go to Statistics, and it will show you statistics for the column that you right-clicked on. So right-click on Area Acres, look at Statistics, and you'll see that the sum of area acres was 385 acres. Now, if you look at the methodology, the way these observations were made, you'll know that that's probably erroneous, and part of your job as an analyst would be to sort of predict the kinds of things that would be missed, you know, whether this is likely to be an overestimate or an underestimate. You can think about that for your homework. Another way to do a summary, which is quite cool, let's say you are interested in a subtabulation of the number of acres according to what the final land use ended up being. So I'm interested in knowing the total amount of land that went from industrial to residential, for example. This 10 reflects, if we go back to the metadata here, 10 is multifamily residential. Well, that's an interesting category. And what if I wanted to know how much industrial converted to commercial or open land? So another really nice way to do a summary when you're interested in a subtabulation is you can right-click on this column, say Summarize, and then say for each LU 37 1999, actually this will be simpler if we choose the 21 class code, we can say for each of the 21 land use codes that exist in this table, in these 44 records, give me the sum of the area in acres. And we'll put this into my Scratch folder. In my project, we'll go here into my categories tutorial projects. I have a simplified land use project here. Since we were just fooling around, I'm going to create a folder called Scratch. And this will become indconv.dbf. Even though we've given a dbf suffix, which would be a nice portable database table, we have to save as type dbase table here. And so this is going to comb through all of these rows for each unique value of LU21 1999. It will give us a sum of the acres. We'll add the resulting table to the map. The table of contents switches to list by source as opposed to the usual list by drawing order. When you're listing by source, then you can see the tables down here. And so this is industrial conversion, and I'm going to open this. So here you see each of the land uses in 1999 here, and you see the total acres of the land here. This number represents the total number of acres according to this data set that was industrial in 1971 and is now 6. What's the biggest? Let's sort this. Descending. So the most amount of land converted from 16 to 17, and that would be to urban open, which you'll have to take into account. That includes all kinds of stuff, including institutional green space. This is a very broad category. It could be vacant undeveloped land, or it could be a campus, including, I think, the Arsenal Mall. So categories can be a little bit lumpy sometimes, which is also something I write about in the tutorial notes you can read. So that's a summary. In the language of relational databases, a summary like that is known as a group by. You would say, give me the sum of area for these polygons and group by LU21 1999. That's the way you would say that if you were speaking in SQL. ArcMap has all these right clicks and everything like that when you're really a hand with SQL, you simply type SQL scripts and run them. But and there are ways to do that in ArcMap if you want to do that. So let's just review a couple of these things. We've just looked at how to do queries, SQL queries in ArcMap. You can do them either from the attribute tables. Here, going to the full on land use attribute table. You can select rows with the Select by Attributes tool here. It also has the help for SQL expressions that you can click. You can also enter queries into the definition query, which has the same query builder. Either way you do it, you can, the result is a new table called a relational view, which is a virtual table. It doesn't exist anywhere on the hard drive. You should save your work, and those tables will reload when you open this project again. You can also save them. If you want to save that offline, you can save this as a layer file, and the view or the definition query will be saved with the layer file as one of its properties. Summaries are done as you saw. I won't review that, but the summary tables are saved as actual tables, like this industrial conversions table here, and you can retrieve those. The DBF is a good format for working with tables in ArcMap. So now let's look at the second piece of this tutorial.